And over to you, Howard.
Oh, great. Thanks, Debbie. Thanks for that. Lovely to see everybody. So this is our How to Analyze course, and one of the unfortunate parts of the current scenario is that big data is not an element on its own, but it's referred to within the data warehousing and BI exam. So, and of course, for me, I feel that's probably the best place to fit big data. If we were to choose which knowledge area or which area on the wheel we would put big data, I think the best one would be data warehousing and BI. So the way I see it is that both of them, being data warehousing and BI and big data, is around decision support. It's there to help us make the decisions and get insights. Either way, it's how do we provide insights? And I suppose the most exciting thing about this area is it's probably the first time that business start to see real value of the data and all the effort that they've been putting in. Okay, so if we look at that data lifecycle, and what I like to do is almost show people the value that we get out of the different areas, and certainly data warehousing is where we start, and that's the use and enhance, and then it goes to big data. Well, big data is the enhancement, and then it will go back into planning. So the business is paying for lots of money, lots of work until it gets to use, and we then have to keep going to get to enhance. And I like to use that DICWA triangle, that data, information, knowledge, and wisdom. And one of the things we should be doing as part of our data strategy is to say, how do we get the data, all of our data assets, how do we elevate them to the next level? So if it's currently sitting at data, can we get it to information? Can we go from information to knowledge and knowledge to wisdom? So can we improve the insights that we get from these different data sets, data assets? All right. So to me, I like that one approach that Beam had, where they created the 5 wives and 2 husbands. So I'm sure you know the first H is for how, and the second H. Anyone have a guess as to what the second H would be? So it's who, why, what, when, where, and then how, and then what would the second H be? Any ideas?
The when?
No. So we got the 5 whys. So that's when, who, where, when, where, and why. And then we've got 2 H's. So the first H is how, and that would probably be a business event or something like that. And then we've got the other H. Who knows what the other H is? If you think
I'll try how many.
Yes, that's right. How many? So it's all about those measurement fields. So it's all the measurements, it's the quantities, it's the amounts, it's all that. It's metrics, basically, the how many. Again, so helpful to almost label your different tables and elements as to what part they're resolving here. Thanks, Drew. Okay, so what we're going to do is go through the DMBoK, and then I'm going to show you some of the differences between revised edition or DMBoK version 2 and the revised edition. Okay, so if you're going to be writing the new one, then it's helpful to know what the differences are. Okay, especially if you've been using version 2 and then the revised edition is coming along. And for those of you that probably have been waiting, DMBoK version 3 is about to get going. I'm part of the editorial board on version 3, and at some stage we'll be reaching out to anybody that's around here that we can to help us review the actual writing and make sure we haven't got spelling mistakes or we've said something that shouldn't be there. So I know I was involved in version 2 and it's a massive job. I also know that there were plenty of mistakes and there's still mistakes. So we'd really appreciate your involvement, just working through it and helping us get that right. So here's basically a mind map of data warehousing. So, oh, yeah, that's strange. Oh, okay. So it's back. Okay, so if we look at the introduction session, it's understanding the definition, it's
Howard, it's
understanding
not
the
back.
goals. Sorry, Drew. Is there a
It's
hand
not
up? Paul.
back.
Sorry, you
Can't see
stopped
your
sharing.
screen.
Sorry, Paul.
No, I'm just saying it stopped sharing.
Oh, thanks, man. Thanks. I was wondering what flickered there. Thank you.
Cool.
Okay, great. Thank you very much, Sam. Okay, so that's the definition that we have. Then the goals: maintain a technical environment and technical and business intelligence activities, and to support and enable effective business analysis and decision making. Now, I know when Drew and I started on this field, it was called decision support, DSS. And then at some stage it changed to business intelligence. And I still like the decision support, the term, because that also for me includes data science. So all of them are helping me and the business make decisions about what's going on. Okay, so business drivers, support, compliance, operational support. So how do we support operations in understanding what's going on, helping them make decisions, and then getting innovation based on insights. So both this one and big data are very focused on what can we change or what can we improve in the business from the insights that we're getting. Okay. The principles, it should start off with the business goals, start with the end in mind. Remember that in-mon one where you try to understand everything that would come into an enterprise data warehouse, and then so you're thinking globally, but then you start building locally. So almost one subject area at a time. You would build the data warehouse and then the data marts. Summarize last, so please don't bring in aggregated data from your applications. I almost like to suggest that if you can get down to the lowest level, then that's a nice way to help you archive your applications. Okay, so if your applications, they can always benefit from keeping them as thin and as small as possible. Let's get it out into the data warehouse environment. And of course, after that, you're going to go into some form of disposal where you would archive and dispose the data depending on your retention cycles. And that would have to ensure that you aggregate so that you can remove those details. And I really enjoyed this approach. I was working with a customer and we were having lots of I/O issues. So there was an ATM database. As the ATMs came on, they were logging their data, and we were having problems with the disks, and that was before the cloud came about. And one of the things that I think it was 2012, SQL 2012 or 2014, they introduced in-memory databases, and we then went through a massive process of getting as much of the information out of the application so that we could go into memory. And just the performance improvement was radical. So that was the first time I experienced this idea of using the data warehouse as your archiving strategy. How do we get the data into the data warehouse, out the application, and then summarize it later on? So the next step would be, and especially for the use in terms of data strategies, how can I then work on aggregate data or trend data? Self-service, this one is developing tremendously, especially on and with the self-service, you definitely need a reporting strategy. Okay. And of course, these days they're using self-service to build regulatory reports. And I've seen a lot of value on that. And I've also been involved where I was a BI developer and we were trying to get this pixel perfect report. And it was really hard. And in the end, we had to go back to SQL Server reporting services because we couldn't get the perfection in our reporting tools. So that frustrated me no end when I was doing work on this visualization when, I thought other people could do it, and it just took me a long time. Okay, then we look at the governance. So make sure that you only go live after the business acceptance, the data marts, user satisfaction. So business acceptance should be balancing and consistency across your logical data sets. So how do you ensure that the business is signed off and you've got the appropriate level of quality? And then we should always be checking our user satisfaction, SLAs. One of the big things on doing all this data movement and ETL, when you have a problem in terms of the quality of the movement, what do you do? And how do you get the data ready for the business people that have to make a decision at 9 o'clock in the morning? So now your life changes somewhat in terms of if they have to have the report, then if you have a problem at 2 o'clock in the morning, someone's got to deal with it. Someone's got to make sure that it's ready and available. Implementation, readiness, release roadmap, that should adhere to the Moscow approach. I don't know how many are you aware of Moscow? Who knows Moscow? Who's dealt with that in terms of a release roadmap? Anyone aware? Drew, you should know from your fundamentals.
Forgotten it.
I wasn't the only one.
Veronica?
Now I know what it is, but I wasn't the only one.
Can hardly hear you, Veronica.
Sorry, my knowledge of acronyms is so bad. I need to just look it up. But it's something about must do now and
so
and
yeah,
and
it's must, ought, should, could, must, ought, should, could, or would. All right. So it's just a way of us prioritizing what areas we should work on and helping build a release roadmap so that business feel included. So in this quarter, we're going to do these, and in that quarter, we're going to be doing those. So you should be building the Moscow definition across all of these areas. Configuration management and cultural change, those are part of the implementation. Change is going to be part of the implementation of any knowledge area. You're going to have to bring that in. Okay. Different tools, of course, metadata repository, data integration, reference and master data should be supporting that. Different techniques, using prototyping, self-service BI, data audits. Then we go into the architecture with a warehouse and those different areas, and then your technical tracks that you're working on. And these are basically the processes that you're going through. Okay, then when we get to this level, it's load processing. So we have to talk about the batch, CDC, real time, and then getting all your historical things in. And then we'll talk about the difference between Inmon and Kimball and Data Vault. Okay. Then when we go into the storage areas, we're dealing with the different types of cubes, OLAP, ROLAP, MOLAP, OLAP. I'm wondering how many of you remember any of these. How many of you guys have got experience? I think it went out somewhere around 2012, SQL 2012, 2014, when they introduced the tabular model. So it was, a lot of it's running in there. What I found is they called it the tabular model, but inside the tabular model were cubes. So they're still using that under the covers, and it's now referred to as a tabular model. Data storage areas, okay, staging, and then we get reference and master data, centralized data warehouse, ODSs, data marts, these different areas. We need to look at the data integration, and then we have these two different warehouse approaches. One is the Inmon and Kimball. Inmon introduced the CIF, or the Corporate Information Factory, and Kimball was the guy who basically said to Inmon, your stuff's taking too long, it doesn't really work, so we're going to build fact tables and dimensional models, and we will use a conform bus to integrate all of our cubes and dimensional model, so we could build a warehouse and achieve a warehouse by having many of the cubes conformed, using a conformed dimension. And then Inmon introduced this relational model, subject area, subject-oriented, integrated, time-variant, non-volatile. We'll go through those at different levels, but helpful for you to understand what that is. And then we've got just different types of data analysis. When it comes to BI, what are those different types? Okay, so that was basically a summary of every single aspect within the DMBoK. And there's your high-level description. Okay, so that was data warehousing and BI. When it comes to big data and data science, these are the important areas of the summary of that chapter. First of all, it's this architecture, or the big data architecture. So you can see that, yes, there is a data lake, but that doesn't get rid of your centralized data warehouse. And nowadays, and lately, when I say lately, in the last 2 years, they started creating the data lake house, which is trying to bring a lot of this warehousing on top of the data lake. So what they're trying to do there is almost standardize the transformation and provide a regular processing of the data into the data lake, of the data lake into the warehouse, and so that it's ready for operational use the next day or whenever it was necessary. Okay, so these elements are still going on. The important thing to recognize is that what you want to be able to do is bring some of the results from your big data back in to your data warehouse. I remember I think it was about 3-4 months ago, we were sharing that there's just been a claim from an individual from a data privacy point of view that a certain organization made a decision not to afford them certain amount of credit. And 10 years later, this person took the organization to court to say, this is the impact that you've had on my life since that time. Now, what had happened was that the organization was not storing a lot of the results about who was rejected, who was accepted, what was the reason for it. It was a machine learning model that allocate or made the decision. And they were in some trouble there in terms of trying to get evidence as to why the person was rejected. At the end of the day, the individual was awarded damages. I don't know how much, or how much they were given, but especially when we get into digital decisioning, now I do know that they are basically suggesting with high value decisions and important decisions that they should introduce human into the loop. So they're probably recording it, but we need to be aware. We need to be aware of that digital decisioning. So bring it into the big data results and allow it to move down the journey. Okay, Now, the other thing that's important, and this was the Robert Abate information triangle, and he connected this basically the DICWA that I was talking to you about, data, information, knowledge, and wisdom, and he connected smart data to this area over here. And what is important is this master data link. So what we're trying to do there is, as we're having streaming data, social networking data, when photographs come in that are potentially about our products or about our people, our staff members, what we need to be able to do is validate that this information that we're collecting is about us and it's not about a competitor or anybody else. That's what you want to do, is to ensure that you're not collecting all of the data that TikTok or Instagram is doing it, but you should be focusing on the data that relates to you. Now, how do you do that? That's by making use of master data, and that integration is connecting from the transactions or the information you get in the data lake to your master data to bring in that context, contextual information. Okay, and then we have the loop that goes on that we have. That's understand the business need, choose the right data sources, ingest the data, and then develop your hypotheses, and then integrate and align the data for data analysis. So it's in this step over here, and that integrate and align would be connecting to your master data and then also connecting to other data sets and making sure that your grain's right and you're not doubling up or whatever it is. So that's the alignment phase. And then you'd explore the data using the models that's appropriate for the hypothesis that you're doing and the state of the data. And what you then do is monitor those data sets to understand the level of false positives and false negatives, that almost the error rate before you get into deployment. And once you're in the deployment, then there's going to be a lot more insights that are coming about, and those more insights are going to lead to more data requests. Okay, so the loop's going to go round and round, and you'll find yourself getting into this cycle of having to produce more and more data so that we can answer more and more questions. Always the question from a governance point of view is, should we be looking at this data? Is this the right data to go and get to us? And then what was some of the provenance questions around the data sources? Okay, that's also very important in your self-service strategy. Where did this person get the data from? Did they just connect to the internet or connect to the web and they downloaded the data? Has it been vetted? Have we done some due diligence on the data? And it's always helpful as executives or people like that, when you get presented data, especially from the outside, it would be, where did you get this data? Have you done any vetting or validation on the data? And if it's through normal authority bodies like Stats SA or something like that, that's great. But how do you ensure that you're getting the right data? Okay, so this is version 2. This is the definition of data warehousing. And just to read it quickly, because I know it's coming, the revised edition, can you see they've made this change where they're talking about an integrated data system? So this is bringing data from all over the place, from different sources, and doing the integration. Okay, so that's a lot of what your data warehouse is doing for you. Now, version 2 didn't mention that integrated data system. They just said provide decision support. Okay, so they were missing the integrating data. Okay, so that's an important change. And then within big data, the big change was they removed these questions that are not known at the start of analysis. And they replaced it with this situation, which is handling of large amount of data, which is your big data, and paradigm and statistical analysis on data science. Now, I don't know how many of you have seen this change, And does anyone know what we mean by paradigm? Any takers? Can anyone explain what is meant by paradigm? Nobody? Okay. Well, that's good. When I saw this for the first time, I thought, shucks, I'm not sure I understand. Initially, I thought it was, and my experience on big data had been, I needed to understand the state of information, whether it was known, unknown, known knowns, and things like that. And depending on where I was, I would choose an approach for analysis. So would it be confirmatory analytics? Would it be exploratory analytics? Would it be digital decisioning? That was my initial thinking. And now in terms of doing some further research, I've realized that there's a lot more to this paradigm than I thought, and hopefully I can share that with you today. Okay, so that's the data, and it's there to find different types of data to find answers and insights. Okay, that's the new definition of data science. Okay, so everything's about finding answers and insights. Now, if we look at the BI, we're really looking at what has happened and why did it happen. And then we'll go into understanding what will happen. So once I know these things, I can look at cause and effect. So what happened typically comes from your BI, and then you need to be explaining why did it happen. So can I see what has changed, and then what's the cause? So the what has changed is the effect. I'm noticing that there was an increase on sales or decrease, and then what caused it? I need to be able to answer that. And I always like to challenge my data analysts, my data scientists to say, specifically when we're talking about business performance measurement, you should be able to answer the 5 questions. What happened for every period? Why did it happen? What will happen if we keep on going like this? What will happen? And then what should I do? And what don't I know? Okay, so we should be able to have these discussions with the executives to share the insights with them. Okay. Now, when we look at the activities, this is the new set of activities that have been coming on revised edition. So you saw that loop that it was going in. There we can see, understand the big data strategy and the business needs, establish the environments, choose the sources, acquire and ingest the data, develop your hypotheses, integrate the data, explore the data, and then communicate the output to the stakeholders. And that would be data insights and findings, and then data storytelling. So this is where data storytelling comes about. Okay, and then of course the data visualization, and we would be constantly monitoring the performance of the model, and then if the performance is dropping, how would we enhance it? And there's something called model drift. Does anyone know what model drift is? And that's a term that you're now going to get involved with in terms of the model quality or assessing a model quality. Anyone know what model drift is? I'm going to ask Adam. Adam, are you aware of model drift?
I would
And
guess.
Could you guess? Yes, that's good.
It's just where what's happening in reality is moving away from the model that was there beforehand.
That's correct. That's exactly so. Adam, I'm sure you're aware of when you build that model, you're going to get into feature engineering, and then a lot of the times you have to go into feature reduction to choose those features that are the most important in terms of the cause and effect. And what you may find is that other features are now in play that are affecting the model, the performance of the model. So the model's drifting, and it's not giving you as the valuable answers that you need and insights. So great. Adam, have you experienced any of that? You seem to understand that.
I guess things always do.
Yeah.
A little bit over time, and because I worked so long and with the same things, that there'd always be some drift.
Okay. And what they do talk about when they talk about data ROI, or the value of your data assets, if you don't pay attention to the model drift, you may value your assets at a certain level, but because it's drifting, the error rate's getting higher. And then they actually talk about something called a haircut, that you would apply a haircut to your value assessment, and you'll reduce the value of your data asset. Okay, so it's important when you start getting into data ROI that you're monitoring the drift and monitoring the quality of the. Dennis, I haven't heard of data drift. I'll look that up and see that. Dennis, are you aware of what data drift is, or? The formal definition of data drift, that when statistical properties of the data change over time. It's the same thing, Dennis. It's the same as the model drift. So those statistical properties in terms of correlations, remember the correlations, a positive and a negative correlation. There's your data drift happening over there. And concept drift. So those are the different types that you've got. Dennis, does that make sense? So I believe we're talking about the same thing. You'll probably find that the data is drifting, which causes the model to drift. So yeah. Okay, great. Thanks, Dennis. All right, so this is the data manager. These are the areas that you would be responsible for in the data warehousing, and then in the big data. So if you're in charge of one of those practices, these are the areas that you need to focus on. Okay. So in big data, it would be the operations plan, the model performance. You'd continually monitor that and put in place something to enhance an enhancement plan that needs to come about. Okay, so this is the how many that we spoke about. And these are the different metrics that you can use. The usage, the loading and scanning, now that's into your data lake. How quickly are we ingesting and cutting up these big videos and things like that? How do we ingest them? What's the time taken before they're available for use? Learnings and stories. So storytelling is very helpful in big data to see what sort of insights are you getting your people, in your business people, to see. And I'm sure you've seen those innovation hubs where they've got cameras and videos. And that's what they're trying to do, is they're actually trying to catch people with those aha moments where they say, shucks, I've never seen that before. And that's a valuable report that you need to do. Now, you can see the difference between big data and BI and data warehousing. Sure, data warehousing is very fixed. It's part of that Moscow. You have a release roadmap and you keep on going. Whereas big data, you're going to be going around that loop and understanding more and more. Okay, so that's the architecture that we've spoken about. These are the different types of analytics. So can you see the different questions? What's happening in the business? Why is it happening? When will it happen? Now, what should I do? And then what is required to do more? So it goes from information, insights, decision. That decision is very important. So you provide possible responses to what's happening, and then you'll monitor the action and then see how we're responding and what sort of good decisions are we making. And this is sort of what I've tried to put here. And this is what's known as your maturity, your AI maturity. So how far is your data going from data enabled to data led to data driven to knowledge driven? Okay, so you can rank your level of maturity by what questions your data can answer, and you're trying to get as high up on the scale as possible. So I'm actually seeing maturity assessments go through and with the data for big data to say, well, what level of questions can we be answering with the information that we have? All right, this is the corporate information factory. And then the big question is, what about Data Vault? So we still haven't got a lot of updates within the DMBoK revised edition. Veronica, I don't think, did you see much in terms of Data Vault? What surprised me was when I wrote the exam, all of a sudden there was Data Vault questions in the exam, but very little in the DMBoK. I don't believe revised edition brought anything more into BI in terms of Data Vault. Veronica, do you remember any of that? Okay. All right, so here's Data Vault for enterprise data warehousing. Now, one of the things that surprised me when I heard all about this Data Vault, what had actually happened. Well, what they did do was Data Vault replaced InModern in this movie, in this area. So this was referred to as Data Warehouse version 2, where InModern, that whole consolidation type of stuff was being replaced by Data Vault model. Okay, so that's what came about, and so the Data Vault replaces the relational model in EDW. Can anyone tell me, have a guess, why did people want to replace the relational model in the enterprise data warehouse? What was the key problem with a relational model in enterprise data warehouse?
Unstructured data.
Sorry, sir? The use of
Unstructured
unstructured data.
Yeah.
Okay. I saw Paul. Paul,
Howard, is
any
it,
comments from you?
Is it just from a conversation I had with you before and talking about it, is it speed?
Yeah, there's certainly a speed, and there was also the problem that we had with the relational model was there were too many constraints that were in place that prevented data from coming in. Okay, so if we look at something like customer, and we know that customer goes through many different stages. So as an example, when you first meet the customer, when they first come onto your website, they referred to as a suspect. That's their name, suspect. And then when they express an interest in a product, they become a prospect. Now, a suspect, the only information that you have about that person is typically the IP address or some information about the location, some of the web browser that you've got. Now, there's quite a bit of people coming on there that are related to a campaign, and what you'll find is, how do I get that recognition into the data warehouse? How do I bring those elements in when I don't know all of the core details? So the impact of relational model that has those strict business rules and cardinality, it delayed data from coming in. Now, when you go to Data Vault, all you need is the customer code. You don't need all the satellite data that's where you'd be storing some of that unstructured data that Drew spoke about. But now all you need is, I have a code for this customer, and as they progress, I can now start attaching other data to that customer code.
Okay, cool. Mm.
All right. So that was the important one, is that every hub needed a business key, and only a business key, to get into the Data Vault model. Okay. Whereas when it was in relational, sometimes it had not null on this, and you would think, if you think of a business key for a customer, shucks, I'd at least like to know his name or the ID number or something like that. And that just stopped a whole lot of data coming into the enterprise data warehouse. Okay, so this is what we did. That's how they started to bring Data Vault in. Now, here's a diagram on the elements of the Data Vault, and this was actually asked in the exam, as the difference between a raw Data Vault, okay, and a business Data Vault. And so what we can see here is we go into loading and staging, and from here we get into a raw data vault with hubs and links, and from there we get into derived extra business rules with point-in-time tables in terms of some of the changes that are happening. Now, this raw data vault, I found it really helpful. Drew, I don't know if you've ever seen a raw data vault, but it's really nice from a data quality and a data warehousing design point of view. Because in your satellite tables, you've got the view of the customer per data source. So now you can be comparing all of the attributes across your different data sources in the staging area, okay, which makes it great for building your master data model from all of these different attributes. Drew, have you seen that in action?
I've not been fortunate enough to know.
Okay. So it's both, when you get it into the data vault, the nice thing about that is A, you're starting with the building of your data warehouse. B, you can do the data quality assessment across the data sources. And C, you can now be looking at what are the different data sources. You can go and do those trust rules on the data sources. You can do the assessment all there. And you don't need to be going back to the original source elements. You can work with it at this raw data vault area. So nice to see that that's almost the stepping stone. So you're paying for the prep for data warehousing, and you're paying and you're getting the data quality and master data development coming out of here. Okay. All right, and then we know the approach that Kimball took, and he built this data mart that was conformed with the conformed dimensions, and that created the bus. The conformed dimensions, for example, customer, product, they kept all of the data marts together, so you could analyze, for example, sales and finance. You could bring the two cubes together and look at the data at the same time. Okay, so I just wanted to now spend some time with you explaining this data science paradigm. So I thought it was fascinating. I actually found the source, the first person that defined this paradigm, and this was the paper. And when you go and look at all of these papers, this was the guy. His name is Jim Gray and Alex Salatze, I can't remember, and they were the ones who built this new paradigm. This new paradigm. So let me explain this thing. And he referred to it as the fourth paradigm of science. Okay, which was quite interesting, because then when we go back, the first paradigm was that empirical paradigm. And what the scientists did then was mainly describing natural phenomenon. So this happened, or the moon went around the sun, Copernicus and all these different things, and the drift that they discovered there. That was the way they did something. From there, they moved into a theoretical paradigm, and that was the use of mathematical models and generalizations that they started applying. And then the third paradigm was computation. Okay, and that was simulating complex phenomena, and then the simulation would show them what was happening in the system. Okay. Now they've gone to a level further, which is data exploration, and they call it, he named it e-science. That was before it became data science. He named it now, what he was working together was, it's actually unifying all of these areas, and you're building massive amounts of data, and then you could engage with the data to understand what was actually happening, and to develop exploration. Okay, and I'll share some examples with you there. So now this was basically what they were doing, is they were integrating experiments and instruments, other archives and other literature and simulations together in a big data warehouse like this. And then the data scientists were engaging and asking questions of all of this integrated data, to be able to understand what was happening. So they developed this extended information, which was, I mean, you'll realize that or recognize that that's the extra metadata, the extra knowledge about a discipline. So they're getting from other archives, from research paper, and they were using RDFs from academic papers to integrate into this big data warehouse or data lake to understand what was happening. Okay, and then we had, above the extra information that they were integrated, they were also building computational models and complex algorithms. So any discipline that you're dealing with, you're going to find extra information and then complex algorithms that need to work together. So you've got extra information, computational complexities, and then data exploration. Okay. And he spoke of this world that comes together. We've got computer science, the domain, the business domain that you're working in, and then mathematics. And these all, when you integrate all three of them, you get the world of data science. When you integrate computer science and statistics, you get machine learning. Okay, so this was those three domains coming together. And they broke it up into multidisciplinary, which was the first step, and then people worked individually, computer science, that's where they worked, or application, or mathematics and statistics. And then interdisciplinary was the multidisciplinary plus understanding how the systems work together. Okay. And then they now have progressed to transdisciplinary, where everything needs to come together. This is where data science is playing the role, and the way in which things work and the boundaries gave us a more holistic understanding of the system that things are working in. So this is basically how they've built and how they built these different areas up. Okay. Now, the key elements to a data science paradigm is acquiring the data, and there you see collection, cleaning, integrating, transforming. And then we go into exploratory analysis. We can be using statistical analysis, data visualization, and hypotheses testing. So that's, you define an hypothesis and then you probe, and depends on whether it's confirmatory or exploratory. If it's confirmatory, you say, we believe this is going to happen. And then if it's in confirmatory, you'll do predictions or whatever it is, and you'll confirm that your hypothesis is correct. Whereas in exploratory, you would have to probe over and over again to see whether your hypothesis stands up at different levels and different approaches. Okay. Now, then we've got, once we've got this exploratory done, we're going to model building and training. And this is where we're talking about the feature engineering and then model selection. Okay, so model selection would be almost a reduction of the features, of the core features that we want, and the design on that. Then we would train the model and evaluate the model. And once the model got to a certain level of quality, it would be deployed, and then we would be monitoring it and to ensure that it wasn't drifting. And then at that stage, we'd be getting into interpretation, this data storytelling and decision making. So this is what's referred to as the paradigm, the data science paradigm. Okay. All right. So what's important here is data science needs data management. So all of this simulation, all of this experimental stuff that we were talking about in this one over here, we need to bring data management into play. Okay. So we can do simulations, we can do experimentation, user behavior, customer data platforms, and now they talk about bring your own lake. So Snowflake has got into this new one where you can bring your own lake, and Snowflake will build this sort of virtualized view of it, and then you can then analyze the data. Okay. Now, the problem we were getting into with science and statistics is a lot of the science and statistical methods were used on single files. Okay, but the data is getting so big and there's so much information in the lake that this single file usage tends to bottom out, and they can't work with enough data to get some of the analysis happening. Okay, so this is where I like this view of it. Okay, so data analysis is looking for needles in haystacks. So there we've got a view of the needle, and then this is our haystack. Okay, but this haystack is becoming massive, and you're wanting to be able to scale the haystack to add more and more data to the equation so that you can get a better understanding. Okay, now needles are a whole lot easier to understand than haystacks. So what we have to do is we have to look after this haystack. We have to be able to integrate, we have to be able to align, we have to be able to aggregate, all the sort of things. And this is where data management is having to come in to make sure that our haystack is right before we start looking for needles. Okay, is it at the appropriate level? And this analysis requires this transdisciplinary integration. So I've always been amazed at how much we need to know about the application domain before we can do data analysis. So we can't just have a mathematician come in or a statistician come in, not know anything about the environment or the domain, and start delivering value straight away. They will take some time to understand. They'll need an SME, they'll need an expert to interpret some of the results to help guide them with the analysis. So you can't just work on this thing just applying mathematics and statistics to it. Okay. Now, this is the problem that the scientists are finding, is that the data delivery is hitting a wall. And some of the models they were talking about was astronomy models. And I don't know if any of you have seen, or they call it a worldwide telescope, where they've got 20 observatories or more around the world. All of them are looking at different areas and feeding the data into one big data area. And so they're talking about many petabytes and terabytes of data, and all of the file by file analysis just wasn't working anymore. Okay, so they did an assessment there of being able to grep or search a file. A petabyte will take 3 years. Okay, and an FTP, a petabyte, will take $1 million. Okay, so how do we get around that? Well, we introduce data management, and we do indexing to limit the search. That's what Google's been doing, to be able to index all of the files in there, and then we can search on the index before we jump into the data. And now that allows us to do parallel search and analysis. So we've basically, what's been said is we need to do the analysis on databases and not on files. We've got to progress. So yes, it's nice to have those data lakes, but we've got to get it into a data warehouse. And that's what Inmon came about. I mean, it was only a year and a half ago, 2 years, where he introduced the data lake house to be able to bring all of this stuff into a data warehousing approach. So statistical analysis deals with creating uniform samples, data filtering, relevant subsets, and we still need data models and controlled vocabularies to help us do this. We can't bring this data together without these two capabilities, data management capabilities. Then when we look at completeness and censoring bad data, that's going to be data quality and data handling ethics. And then we get on to basically the BI side of it. There's certain procedures that we can automate, and we can do the what and why in terms of that. And then we get into the more hypothesis and likelihood calculations with data science. And here is where we are able to improve these tasks with a structured store. Okay, and there's your data storage and operations. And I don't know how many of you have started to see now lately with, I know Microsoft has done that for a while, where they now allow you to write R and Python routines and actually store it in the database. So when you issue a query, these R and Python algorithms have already been running in the data, right next to the data. So you issue the query and just the answers come back, and there's no processing being done on the workstation. It's all happening within the server. I don't know how many of you have seen those latest developments that have been happening in this area. And then, of course, we get into visualizations, BI and data visualization. So a lot of your data management skills and that are still required in these areas to build this platform that we need to scale on our big data. Okay. So again, these are the paradigms that we talk about: capturing the data, curating the data, analyzing, publishing the data, then doing some form of peer review to say, well, have we done everything right? Then providing access to the data and communicating. And what was interesting was looking at the costs of where all of this stuff is sitting. So interesting, the data platforms, they're talking about $million. So they measure the cost of data platforms in $million, meaning 1/millionth of a dollar. Okay. And then the schema and ontologies and provenance, these are the two areas that are costing the most in terms of data science. These two areas over here, and then we get a drop off coming down to the different data publication, review, and access. Okay, now over and above this, we need, because we've got this data all over the place in many different data sets and things like that, hence the data catalog. Now, the data scientists refer to this as a digital data library because they also publish research. So if there's a data set with a model, they're also publishing their research, and that can be part of the library. Okay, so they've progressed really far on this. A lot of us, and I certainly know in some of the organizations I've been to, the catalog has just got the data sets in there, the data assets, and some of the metadata that they have, and linking to our business glossaries. Now the scientists have got all of those things together, all the research papers, all of the commentary on that, they are bringing it in. Okay. Now, a very interesting comment that they made was, these days, most data is born digitally. Okay, so it's the sensors, it's the IoT devices, it's generated by simulators. And so that's what's causing our increase of data. Then we've got this massive distribution of data sets, and we've got data on all scales, and there's value in both small and large data sets, and we need to know where that data is, where that value is, and that's what the role of the data catalog is providing to give us that view. All right. So that was my view. That was the summary of these two different areas, and the importance of a data manager. Are there any questions, comments, anything that you'd like more detail on? Nothing.
Thanks, Han. Great.
All righty.
No, it's great and makes kind of clearer why for data warehousing.
Yeah.
Yeah. So that's always something that bothered me. I don't know about Drew, but I got quite nervous because Drew and I spent the last 25 years in data warehousing, and then the big data comes along and it's like, oh shucks, I'm going to throw it away. But it's amazing how we still need to be going back to those things and then helping to bring all this world together. One of the biggest problems they find with the data lake is inconsistent transformations across multiple data models. So because each data scientist is going to the lake, getting the data out, and because there's the strength of the metadata is not strong enough, this person may interpret this attribute as meaning this, and that person is meaning that. And so we now are rather challenged with all these different interpretations of the data set that's sitting in the data lake. So that's what the data warehouse brings together, is that conformance and consistency of transformation. It's not to say you still can't go back to the lake to look at the data, but at least we've got a standardized view of it. Yes, Drew.
Yeah, I'll probably get into trouble for this, but I think what we had in the past was discipline. Discipline to model stuff, discipline to catalog stuff, and discipline to make sure what we loaded at least had a semblance of reality. It's got too much like a Wild West now, and it's chaos.
Right, and that's sort of why Inmon introduced that lake house, Drew, so that now the transformations out of the lake were being standardized and engineered, okay, consistently. So you're bringing in sort of ETL processes back into the game to get the standardized data.
I appreciate it, and I think I also appreciate the fact that with streaming data, if you streaming data in from a known source on a regular basis, it's consistent as well. I think that's when you get the inconsistency, the ad hoc stuff that can throw people off.
Yeah, and I'm just going to show you the scientific paper or the scientific thing that was done. So here's some examples that he used. First of all, in astronomy, they built this across. They basically federated this whole data set across 20 observatories. So each observatory has their own data lake, but they agreed on a common schema. And you could then issue these queries to all of the different observatories to get what happened at that point in time. So you could have all these different views or perspectives of what that was happening in those areas. And this is where they came into this worldwide telescope or virtual observatory. Okay. And they just spoke about how they're having to bring all of this data together and the size that they're working on to be able to achieve this. Now, one of the comments that I was sharing with Drew earlier on this week was using health informatics. Okay, or coming from all of these different hospitals and these different things, is that they're using ontologies to help integrate the data on different shapes, but they had enough metadata to describe the data sets. So they'd have to go from one ontology to a conformed ontology to get it into the right shape. But they're now able to automate that ETL from these different areas, but they all had to agree on a standard unit of measure and meaning and things like that. So there's a lot of that work that we were struggling with on ETL. They're now able to bring this together in a much larger scale and have more automation around the loading of the data and the curating of the data. That's where we need to get the automation going.
How is that not also a symptom, an indication of moving from ETL to API type practices?
Yeah, Drew, and that integration chain that they build using ontologies is they've almost got a piece of code that is, and they move it from one transformation to another, and they'll apply different ontologies at different times to try to get to the transformation, and it would be happening via APIs. So that implementation of that integration system happens via APIs. Yeah. Now, of course, what you're seeing there now is that because the data is coming at them, maybe one patient record at a time or one smaller data set at a time. It's not as if they're, transferring petabytes of data to be transferred via an API. That could also cause some challenges. Okay. This was the genomics, this structural genomics. This is where they're using ontologies to integrate the GNOME projects across the world. All the different places were working on and doing this analysis on this tree of life discussion. And that's where they've used the ontologies to integrate the data from the different areas. Okay. Great. Any other questions?
Awesome to see those examples of really useful, profound ones.
Yeah, sure. It's amazing to see the speed that they operate. And I think Veronica was also talking about a new telescope that had just been released. Veronica, what was the telescope?
James Webb.
You're too soft.
Oh, sorry. James Webb Telescope.
The James Webb Telescope. Oh, so let me.
Yeah, there's also that Meerkat thing up Sutherland, where they've got hundreds and hundreds and hundreds of kind of listening devices that are all concentrating the signals that they are picking up into a store of some sort.
Right. And this is the sort of store that they've brought down or they've designed. This is what this Gray guy was designed to bring all of this data together to define a standard ontology and semantics of where this data was coming to so that anybody can look at it at any time. And they said it was fascinating. Their first impact was that they no longer needed to wait for a dark night or a cloud in a cloud free. They were able to bring all this data from all the way around the world to understand what was happening at that point in time. So, and these guys could issue the query to any observatory to get the data, which was quite amazing. Oh, it was milli. Sorry, milli is 1,000. Yeah. And centi. Okay. Great. Thanks, everybody.
Thanks, Howard.
Right.
Have a cool
Yeah.
evening.
Thanks, Howard,
Okay.
again.
Thank you, Howard. Appreciate it.
Thank you.
Thank you. Cheers, everybody.
Thank you. Bye.
Bye.
Bye, everyone.